And 2.3, page 2. So this time we're actually going to be solving for the zeros of a polynomial function, and we're going to write it in factored form. So this is example 4. List the possible rational zeros, find all the real zeros of the function, and write in factored form. So here's our function. So possible rational zeros, well, let's see, the constant is 2, so 1 or 2 go on the top. The leading coefficient is just a 1, so 1 goes on the bottom. So we get plus or minus 1, plus or minus 2. And we don't know which of these, if any of them, actually are zeros. So we're just going to try, and we kind of guess and check. So I'm going to start with positive 1. I plug in positive 1 to each of the x's. So I find f of 1, 1 to the 4th, minus 1 cubed, minus 3 times 1 squared, plus 5 times 1 minus 2. And I look out, it equals 0. We want it to equal 0. We are looking for zeros, x-intercepts. So since I found this, I'm actually going to use that with a synthetic. So I put the 1 on the outside. I put the coefficients across. Do my upside down division symbol. So add, multiply, add, multiply, add, multiply, add, multiply, add, and it should end in a 0. If it doesn't end in a 0, we made a mistake because f of 1 is supposed to equal 0. So this was an x to the 4th. So this becomes x cubed minus 3x plus 2. Well, it's a trinomial, but it's not factorable the way we know how to factor it because this is an x cubed, not an x squared. So basically, I'm going to redo what I did here. My possible zeros are still 1, negative 1, 2, and negative 2. And I look out, though, again, if I plug in 1, I get 1 cubed minus 3 times 1 plus 2, which does equal 0. So I'm now going to take this new function, put the coefficients, put the 1 on the outside, and do the upside down division again. Add, multiply, add, multiply, add, multiply, add, and again it should end as 0 because I called this g and we said g of 1 equals 0. So this is now, well, this was an x cubed, so this is an x squared. So this is x squared plus x minus 2. This is factorable the way we know how to factor it. So it factors to x plus 2, x minus 2. So I get negative 2 and 1. So my x's are negative 2 and 1, but the 1 has a multiplicity of 3 because here f of 1 equals 0, here g of 1 equals 0, and then here this factor also gives us a 1. So that has a multiplicity of 3. So in factored form, f of x equals x plus 2 times x minus 1 cubed. All right, and g of x. So constant is 14. So 1, 2, 7, 14. Leading coefficient is 1. So our possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. All right, so I start picking these numbers and plugging them in, and I find out that g of negative 2 equals 0. So if I take the negative 2 and plug it in here, it equals 0. So I'm going to do my synthetic division with negative 2, put the coefficients across the top, add, multiply, add, multiply, add, multiply, add, and we get 0, which we should. So this becomes x squared minus 9x plus 7. And what multiplies to 7 and adds to negative 9? Nothing. We can't factor it, but that does not mean you're done. It means you have to do quadratic formula or completing the square. So I'm going to do quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which simplifies to 9 plus or minus root 53 over 2. So we have 3 zeros. X equals negative 2, 9 plus root 53 over 2, 9 minus root 53 over 2. So factored form, g of x equals x plus 2, x minus this 0, 9 plus root 53 over 2, x minus this 0, 9 minus root 53 over 2. And that's it for page 2. Good luck.